Okay, welcome to developing and deploying applications in a multi-site hybrid cloud. I'd like to start out and thank you for coming to the last session of the summit, right? Everyone's tired, everyone's worn out, everyone's head is already full of great new knowledge and great new ideas. So for those of you who have persevered and made it this far, I commend you. And I'd also like to let you know that this is the finale. Everything has been leading up to this. Sure, there's going to be a great party, but this is the main event. So you lucky few. We're going to talk about what we want when we say a multi-site hybrid cloud. Why would you have a multi-site hybrid cloud? Why would you want to develop applications, deploy them? We're going to talk a little bit about the platforms and environments that Red Hat uses excuse me, to deploy production applications. Then our solutions for actually doing the build and deploy functions. We're going to demo the pipeline. We're going to show you what we actually use to deploy applications today. And then we're going to talk a little bit about the future and where we see this going with all the great new technologies you've been hearing about for the last few days. And then we should have plenty of time for Q&A. I'm Tom Benninger. I'm a solutions architect and systems engineer in Red Hat IT. I work with a lot of teams on how they develop software. I focus on application lifecycle management. And we have...
Hi, I'm Ben Pritchett. I'm the tech lead for our platform as a service team within Red Hat IT. So I help to design and build OpenShift container platforms for Red Hat IT.
Hello, my name is Atanasov, and I'm part of the Red Hat IT application delivery service team. And we are delivering the web applications that many of our customers interact on day-to-day basis when they go to our website.
So a few notes about this presentation in the demo. We are not actually going to change a live running production application. We are not that foolhardy, but we are going to be using the tools to change a hello world application in our production environment. We're at a little bit of risk there. Everything you see here, we could deep dive and spend an hour on any given topic. This is an overview, and then we hope to use the Q&A to find out what you're interested in, and we can deep dive into those topics. So when we say multi-site hybrid cloud, what are we talking about? What do we want? Well, we want to be able to quickly and efficiently deploy secure applications to our customers. Basically, we want enterprise quality delivery. But what does this need? How do we look at this? What do we need to deliver? From our service owner point of view, we need to make sure that we can deliver services across the globe. We also want to be able to cloud burst workloads out to cloud resources if we need to. And we need to make sure that we have disaster recovery, right? If one site goes down, we need to know that we can fail over seamlessly to another site. From the financial point of view, we want to ensure that we can manage the costs on any given cloud provider and we don't get locked into a single cloud provider. From an engineer's point of view, we want application patterns that we can reuse so we don't spend time rewriting the same code over and over. And we want end-to-end automated deployment so that we can get these services, the new services we're building, out to customers quickly. And from the security point of view, we want to be able to show that we're compliant with legal requirements, contractual requirements, our own policy requirements. But we also want to make sure that our applications themselves are designed to be secure. And we want to make sure that we have digital supply chain security. The components we use to build our applications need themselves to be secure. So to talk about this a little bit more, when you're building software these days, oftentimes you have a lot of different suppliers. Hopefully you have Red Hat. You're probably going to have a lot of other open source projects and suppliers. And then you may have commercial vendors in the mix. They're going to give you your raw goods that you start with, right? Your libraries, your modules, some raw code that you're using. Then you have to build your own solution. You have to be able to get that solution out to your services or your customers, and you need to be able to run it in production. Each one of these has its own set of challenges to ensure that you're doing it in a secure and resilient way. And as we walk through our solutions, we'll talk about how we can help you with each of these parts. So I'm going to kick it over to Ben, who's going to talk about our environments.
Thanks, Tom. So what does our hybrid cloud look like? It's right here. We have two traditional data centers that we have included in our hybrid cloud design, as well as a public cloud footprint. All of these sites are currently in North America. We do plan to expand that out in the future. but really we're talking about disparate locations over the United States. Red Hat IT also has other data centers that we manage, but we really wanted to ensure that we scope this appropriately to meet the goals that we were trying to meet with the hybrid cloud design here. So why did we start with 3 sites? We wanted to ensure that we started thinking about scale in the beginning. So if you design for 1 site, it's really not a hybrid cloud. Designing for 2 sites, you may kind of have assumptions you make about how you're deploying to any particular site. So thinking about 3 sites, we thought that's the minimum amount to really get us thinking about scale in the beginning. And we can stamp this pattern out to 4, 5, 6 sites as needed. Additionally, we wanted to account for clustered services that may see split brain issues in the case of a single site failure. So our application teams can now design around that. If a single site fails, we'll have the ability to meet quorum within that service, and it can continue on as a subcluster of itself. Additionally, we wanted to make sure that any individual site only had enough spare capacity to take on the workload that a site failure would need. With more sites, that footprint goes down. At the core of our hybrid cloud is Red Hat OpenShift Container Platform. This abstracts the underlying infrastructure for our app teams, so they don't have to worry about how the public cloud versus private cloud looks. They have consistent storage, network, and compute across our hybrid cloud offering. And right now, it's the default choice for Red Hat IT's applications. So let's talk about some of the tools that go alongside our OpenShift offerings within Red Hat IT. We have this service within Red Hat IT. We call it the managed platform. That's kind of the marketing term we've given it. It's a combination of all of our OpenShift clusters, but it also includes other utility services that are wrapped around it, including Red Hat Quay, a centrally managed Jenkins service, and we use a lot of Red Hat Ansible to automate everything. Why do we include some of these tools? We wanted to ensure that our image registry had the same hybrid cloud design at its core that we were asking our application teams to meet. So in the case of a single site failure, we can still deliver application images via Red Hat Quay with its built-in geo-replication features. Additionally, with our centrally managed Jenkins service, app teams don't have to go to all of our different OpenShift clusters to individually manage applications. They go one place. That's where all their project creation is done. We automate role creation, permissions that they need to get started deploying their applications, all within one Jenkins service. This also improves our ability to collaborate across teams. Everyone's working in the same space. They can share templates, best practices, as they find those successes in their own pipelines. And that includes standardized ways of interacting with centrally located testing tools like SonarQube, and also running things like OWASP dependency check directly in their pipelines. So what are some of the things that we need to consider offering our application developers within our managed platform offering? We automate pretty much all of the access controls that go around an application. So if you think about creating a project and the users that are associated to that project in OpenShift, there's a lot of management that could go into that. Now, times that by 6 and times it by the 90-odd application teams that we work with, that can get really messy really quick. So we integrate very heavily with our identity management solutions within Red Hat IT, so that when an application team creates their projects within OpenShift, regardless of what cluster it exists in, we know who needs access to it and how they need access to it. And we also automate the creation of service accounts that link to like Red Hat Quay, so they can push their images up to there securely. And we also create service accounts that kind of link Jenkins and their projects within OpenShift, so they can get right to deploying their applications without having to worry about who's a member of their project. Another policy that we built into the managed platform was building pipeline as code. And this seems obvious today, but when we started with our container platforms within Red Hat IT, we did a lot of point-and-click design of pipelines. We found quickly that does not scale. So all of our app teams today have to develop their pipelines as code. This makes all the changes that they do auditable, so we can ensure that we can point to what change may have broke a pipeline and who made that change. Additionally, this improves our ability to carry these pipelines possibly over to other services as needed, improves the resiliency of that code. We can just, or of the pipeline. We can take that code, import it into another service, say if this service goes down. And additionally, again, it improves the collaboration across teams because they're having developer conversations around best practices when it comes to pipeline, and they're all looking at code to do that. At this point, I'm going to hand it back to Tom to talk a little more about our solution.
So Ben talked about our clusters there, our OpenShift clusters, and you can see how we're meeting the service owner's requirements of being able to deploy applications in multiple sites and cloud burst and have disaster resiliency just because we can have services running in 3 places globally load balanced. We've also been able to cover a little bit of the financial discussion. If we can shift workloads around and we can reduce the amount of spare capacity we need in any site, that drives costs down. From the developer point, Ben mentioned our pipelines. We're trying to use common tools, common patterns there. So we're beginning to see how this can all fit together to accomplish all of those goals. What we're going to go over now is our actual pattern for pipelines. We made some key decisions. End-to-end automation we've already talked about. We've also designed for modularity and componentization. We've mentioned the fact that we use SonarQube for testing. We have a variety of tools that can do similar types of testing to different degrees of quality. So if we have a higher security app or an application that has data that needs more protection, we may run it through additional tests to meet those security requirements. We've talked a little bit about the, the external orchestration, how we need to orchestrate across 3 separate clusters and 3 separate sites. Part of that is we have adopted a build once, deploy globally strategy. We found that if we tried to take the source code and compile in each site separately, we would have small differences in the artifacts. Maybe the packages hadn't properly replicated or a number of other issues. But rather than try and deal with what happens when small changes occur building locally in each site, we decided to build in one site and then use Quay's built-in replication to get those container images to all sites. We also, to facilitate things a little bit more, said you can't put any secrets, passwords, certificates, those sorts of things, or local environment configs in your container. We use our orchestration system to push those, the right settings to the right clusters so that when your application deploys, it can run appropriately and talk to the local instances of its utility services. This is the high-level map of our process. We start off with independent development. This is where we do feature branch development, and every developer can spin up a test environment to do their own work. Once the developer thinks the code is good, we go through a standard merge process where we do a lot of testing, to a standard build process, again, build once, then distribute, and finally we go to deployment. Deployment is also an iterative process because most teams have at least 3 application environments, dev, integration, and prod, and then we have instances of those in each of our 3 sites. So we need to be able to roll through all the sites before we get to prod and stop if there's any issues. Once we've deployed something to prod, we can then start our development again, or the next developer who's developing on a separate branch can start their merge. This is a little bit finer grained view into it, and we're going to go through this row by row. I realize that's unreadable, but this is the big process. We start off with independent development, and we allow developers to start working on their code, but also their tests and their OpenShift configs. From that, we use Jenkins to allow developers to build test instances using the same tools that we use to build for prod, but this is just for them. We don't allow these builds to go to prod because we don't know what the developer is doing that may be different from our standard testing. This is so that we can quickly iterate our development. Speed is one of the main things we found we've gotten out of OpenShift. our work in progress has dropped tremendously, and our cycle time has dropped tremendously since we've moved to these patterns. Excuse me. We build and we use, in this case, this is modeling Java applications. So we use Maven with the OWASP plugin to check all the dependencies for security against known CVEs and things like that. And we run through tools like SonarQube to check the code that we write for issues, as well as maintainability. And then we build and deploy. Once it's deployed, developers can do their own testing. And when they're sure that their code's ready to be merged in, we move to the merge process. In the merge process, the really key thing that happens here is peer review. We have people look at the code, we have people look at all the test results, and decide whether or not the code's ready to actually be pushed through our process, or whether it needs to go back to the developer to improve the code. Once the code has been approved, we delete all those custom environments so that we don't waste resources, and we start our real build process. This is where we do our central build, and we kick things over to Quay, where we have our data replication. This means with Quay's data replication allows us to more quickly deploy to all of our sites and gives us more disaster recovery capabilities. Then we start deploying. There's only one line here, but in the first image, it actually repeated 3 times. We deploy through each of the dev environments in each site, then we deploy through each of the integration environments, and we deploy through each of the production environments. In each set of environments, we of course do testing. We do heavy testing in dev and integration, and we do lighter validation in prod because we don't want to overload our production servers. We assume that the testing in our previous environments, because it's running in the exact same infrastructure and the exact same versions of software, should be valid. And that's our overall pattern. Now Ivan's going to actually show you that working in real time.
So I'll start with what I'm going to do is basically we have a simple application which is actually deployed in production right now, and it says hello world. And in the process of this demo, I'm going to change that with a more appropriate message. And so in our department, introduction to a new code change starts with a merge request. Basically, that merge request needs to go through a couple of steps. It needs to be peer reviewed. We do unit testing, integration testing, we do a static code analysis, and we do dependency check. Now, I've created one merge request so you don't have to waste additional time of waiting for all those to pass. And once it's approved, it can be merged. And as you can see here, the change is pretty much very simple. Now, when I merge this pull request, it's going to go and trigger our build pipeline in the managed platform. That is where the actual work of building the image starts. And so once that triggers, we use all the shared pipeline tools to be able to take advantage of all the team knowledge. And we share that and kind of go through the process. We use source-to-image builder to build our images. And that allows us to rebuild the images from the source code, save us time. We don't have to know additional information about how to build containers and such. And basically, we also use images from the Red Hat container catalog. We use those because they're always up to date. Security patches or other changes are quickly pushed to that registry, and that gives us ability to be up to date on any security changes we need to do. Now, the build is relatively fast. Of course, this is a Java application. It might take a few minutes. But what I'm going to do in this build, I'm also going to deploy at the same time to development into production so that we can save a little bit more time. And basically, every team, many of the teams use different languages and different frameworks, but as to a source-to-image builder gives us a great flexibility and ease of deployment. So I can deploy Node.js applications or Java application easy or Python application. And once the build is done, we trigger deployment. Now, we use Red Hat Quay for, as Ben mentioned, for our image registry. And what that does is it replicates the readily built image throughout the 3 data centers that are in production. And basically, once the build is ready, we trigger a deploy. And each deploy happens locally, and we can choose to deploy to all the data centers at the same time, or some teams might want to deploy a single site at a time, giving them the time and the ability to verify the deployment. And if everything goes well, they can proceed with the rest of the deployments. So also, as a result, we can scale the deployments depending on different applications. Now, this application is really, really small, so I'm really using just very few pods. And I have prepared a page. We also use global load balancing. Basically, that allows us, for our customers, to go to a geolocated site. And those data centers in AWS Cloud, depending on where you are in the world, you can get to one or another. And so I have those three put in an iframe, so otherwise you wouldn't be able to kind of see the change. And here you can see how the change was deployed, and you can get it from all the three data centers. Of course, you can also get it from a single data center, and you can pretty much go to https://ohc.redhat.com/hello, and you can get that right now. And I'm going to hand it off to Ben.
All right, thanks for that demo. Again, you can go to that website. We'll show it at the end as well, and you can actually get the response for yourself. What are we looking to do next? I'm sure you've heard a lot about operators this past week. We're really excited to start adopting the operator framework within our processes as well. We have a hypothesis that we'll be able to do a lot of cool stuff in bringing the lifecycle management really close to Kubernetes. And so this isn't an operator talk, but I definitely check out the information that Red Hat's posted on operators. And possibly next time we'll have some updates on what that looks like within Red Hat IT. We're also really excited about Kubernetes Federation version 2. This is an operator that you can actually go to operatorhub.io today. And when you start installing OpenShift 4 and working with that, you can include it in your installation and start working with it. It really allows us to manage API objects across different clusters and different sites. And so we're really excited to take a look at how we can abstract some of the stuff that we're doing in Jenkins today and put it closer to Kubernetes again. So there's a link to check out more information on Kubernetes Federation version 2 if you're interested. It's also developer preview in OpenShift 3.11, but again, it's going to be included. It's included in operatorhub.io. So with OpenShift 4's capabilities to install operators and manage their lifecycle, you can definitely check that out. And we're looking to expand this to more geographies and more cloud providers. Like I said in the beginning, we tried to think about scale at first. So considering multiple cloud providers and multiple sites, really we just have to stamp out this pattern wherever we want to put our hybrid cloud. All right, and I think we have some time for questions. If we want to take those now.
For your deployments into AWS, when you access AWS resources, are you using IAM roles or are you using access keys? Specifically about when you need to access the resources in your other locations.
So we actually use OpenShift to abstract all of the Amazon resources away. So Ben's team runs the OpenShift cluster, and they have keys that allow them to provide storage to the OpenShift cluster. But our users just go into OpenShift and say, give me a physical volume. They don't actually access Amazon directly anyway. They may have access keys or IAM roles for specific things like accessing S3 buckets if their application has requirements. And that's really a case-by-case thing depending on what the application requirements are. Tying IAM roles to applications with infrastructure service is pretty easy because you can actually tie the role to the node instance. But with OpenShift, it is a multi-tenant environment. You're going to have multiple applications on the same node, so you don't want to have that tight coupling there. So we do use access keys frequently for that. There's some other things you can do, but I'd say that's probably the default strategy. And a lot of it gets into how secure we need the data to be and what service they're accessing. S3 buckets are a fairly simple service. When you start talking about integrating simple queuing service or other big data solutions that Amazon has, there's just a whole lot of choices there to make.
Could you talk a little bit more about how you manage the secrets and the variables?
Yeah. So the question was, can we talk a little bit more about how we manage secrets and variables? OpenShift has the idea of variables built into it, right? It has config maps, which are for things that are not secure, and secrets, which are for things that are secure. And when you define them in the API or through the GUI, they are sent to the pods when the pods are spun up. They're actually mounted at the file system layer with a memory file system so that you can read those pieces of data out. So when you can also read them as environmental variables. So when the pods launch, we can read that. So that's how we get them from OpenShift into the pods. That's all standard product technology. What we have to do is we have to get them to the different OpenShift clusters and keep them properly synchronized. For that, what we tend to do is encrypt the data and put it into a shared data store, which our Jenkins pipelines can then read. And when that data store is updated, Jenkins actually reaches out to the APIs on each of the specific site clusters and updates the config maps and secrets. So that way we can keep our configurations in lockstep with our actual container image deploys.
Can you talk a little bit more about that external data store? This is a problem that I'm having, right? Because OpenShift and Kubernetes only hash secrets, right?
Yeah. So I believe what we do is we GPG encrypt them and then hash them so that they're in a safe format to transmit. But we use the GPG encryption, and our tooling actually handles the unencryption. Is that about right?
Yeah, that's right. We expect app teams to, alongside their pipeline, alongside their application code, they'll also provide that config and those secrets directly in their code. Now that is encrypted, and our Jenkins process is the only one that has the ability to decrypt them. So we can take a centralized Git repo. It may have secret context for Amazon or private cloud as needed, but it's all stored in one place, and with our centralized Jenkins, it's the one that can decrypt it and put that secret information where it needs to go. And we kind of use a key value methodology within Git so that app teams can tell Jenkins where to put any individual secret.
Very interesting. Thank you.
Can you elaborate on your dev environment? Do you guys give like a project to each developer, or is it
Okay. Yeah, the question was, can we elaborate on our dev environments? It's actually a little bit more complicated than that. We want to be able to tie budget and quota to teams. So what we do is we have the notion of a project group. And within a project group, whoever owns that project group can spin up projects. So they may have a project for each application, or they may have one project that they host all of their applications in, but they can manage the resources across all of the projects in their project group. So what that allows is development teams to choose how they want to manage their dev environments. They can say, okay, everyone uses one single shared development environment, but that doesn't scale well if you're trying to do parallel development. So what we're seeing is that developers have built tools to just stamp out copies of their own project or their own deployment of their application so that they can do anything they need to do without interfering with other people's work. Now, this gets complicated if your application has a lot of dependencies. And so one of the pieces of work we have going on now that we have this great platform that operates in multi-sites, is we're trying to get all of our application stack, the entire dependency chain, into a state where you can basically spin up your own copies with dummy test data. So the limit really is how many dependencies you have. If you have 100 dependencies that are hard to duplicate, you might lean more towards a shared development environment strategy. Whereas if you don't have many or any dependencies at all, people tend to decentralize as much as possible.
And I just want to add something from like development perspective. our Jenkins pipeline, our developers are allowed to supply custom branches, and that a little bit of the tooling that Ben talked, and that tooling then takes that into context, and depending on what type of branch you supply to the Jenkins build, it will build developer sandbox, or it will just proceed with the regular development and other environments. So that's make it like really easy to use, and at the same time, developers are using actually the same pipeline code that it will be used to deploy the actual and to build the actual image in production, for example.
So then do your developers have access to OpenShift or no?
Yes, yeah.
Yeah.
They can log into the console. The pipeline will actually overwrite anything they do, right, the next time it's deployed through the pipeline. And we also, remember, we allow them to do independent development, but what they build does not go into prod. After certification and merge, we do another build, and that's what goes to prod. So it's sort of like an airlock system.
So what's the, if you're referring to applications, what's the scope of that? Is that the downstream products that they're making?
So this is actually for IT's applications. Red Hat has P&T, which focuses on building applications for customers. And then we have our own hundreds of applications to run our stores. You know, when you buy something or when you go to redhat.com, the marketing website, all of this is focused around the business applications that actually run the enterprise. Those we think are actually probably more similar to the average Red Hat customers' use cases than what our products and technology team does. Yes, yeah. We actually work closely with them, and we share a lot of the tools. So Ben is on the IT PaaS team. We also have the P&T DevOps team who manages the OpenShift clusters for all the builds and tests. And that's also separate from our OpenShift online and dedicated teams who run OpenShift services for other people.
Do you then, you custom build all your internal applications or things like packages?
We have a lot of custom applications, and we also have off-the-shelf software as well. It's a mix. And sometimes you have to build a custom application, and we do. And if we can, we try not to rewrite code that someone else has already written.
Yes. Do you have shared storage or do you across all environments?
I'm sorry, what was that?
Do you have shared storage across all environments, or do you?
So we don't. We move the data replication issues up to the application level. For instance, a lot of our services use Mongo, which has built-in multi-site replication, and we trust that service to handle data consistency issues.
You mentioned Quay. Are you using Quay as the registry in each cluster and then use Quay replication, or you use a separate Quay cluster, replication cluster, and then the onboard good old-fashioned off the registry?
I believe we're just using it, actually, I'll defer to Ben.
We use it outside the scope of any individual OpenShift cluster, so there's just one place that application teams need to push and pull from. It itself is geo-replicated as needed, and we actually run it in our OpenShift container platforms, but it isn't, I wouldn't say it's scoped to an individual cluster.
I have two questions for you. You mentioned global load balancing, and I'd like a little bit more information on global load balancing. The second thing was, what do you guys use to keep all three clusters that you showed in sync? Is it just a name-based sync, or are you setting up other customizations within or configurations within the cluster?
Sure. So let's start with the global load balancing. We have several different strategies for global load balancing depending on the needs. So if you go to redhat.com, you can do this yourself. You look it up, you'll see that it's actually hosted through Akamai CDN caches, right? The IPs say that, that's all public knowledge. Akamai provides a lot of good global load balancing services as well. So we just front that type of service with a global load balancer. We also are investing, and this is an area where we're trying a lot of different things out and we're looking at a lot of different technologies, but we want to have a full portfolio of tools. So we're looking at how we can provide just DNS-based global load balancing to the customers who want that, versus a more layered approach where we would use an intelligent proxy plus DNS-based global load balancing to do site-to-site routing as needed for a little bit more, for the ability to fine-tune traffic flows a little bit more. This is a space that we are spending a lot of time looking at right now. You know, the last year we've focused on how to get 3 sites working perfectly together. Now, with just one type of load balancing solution. Now we're expanding our capabilities here. So that's probably something else we'll be talking about next year.
And the way we keep all 3 sites in sync is pretty much through Quay. Basically, when we tag the images, and then when we run the deploy through the Quay, the local OpenShift instance pulls the image. And based on the tag, the image is pretty much always the same.
Yeah.
Was your question targeted more to, I guess, API resources across multiple places?
More of the system configuration, or how the masters are configured, to make sure that the masters are configured the same on all the masters.
The clusters themselves, not the applications.
Yes, sorry, more
Yeah.
on the operating side.
Okay.
Yeah, that could be its own talk. Within our team, we basically have what we call rolling updates that we run every week. So any code that goes into our platform management that my team owns, we're constantly pushing out those updates every week. And so it's kind of the DevOps practice of bring the pain forward. You know, if we're doing it so often, we get really good at our ability to rebuild both the masters as well as the underlying application nodes underneath. And so this means that when we talk about putting applications on our OpenShift container platforms, they need to be able to account for the underlying maintenance that we're constantly doing. Hopefully that answers your question.
Yeah. We also use image-based deployment for our platforms wherever we can. So it's not like we're building a system and we're hoping it builds the same. We're deploying the same image wherever we can. And Ben brought up a very good point there. So we have the automatic rebuilds every week, and whenever there's a critical change, we do a rebuild. This means that applications are getting restarted. Individual application pods, which are load balanced by OpenShift, are getting restarted at least a couple of times a week. And at first, this was a little bit awkward because our applications that which were not designed for that type of environment, it took a little bit of time to massage them into a place where they could handle that. But now that it's become standard practice, we've actually seen developers build more resilient services because of that. So in the end, we consider that a win.
So you said you had 3 sites.
Yes.
Two are Red Hat data centers. One
Yes.
is Amazon, right?
Yeah.
Is there a hierarchy there, or are they all considered sort of?
All equal. One of the things we focused on over the last year is taking some of our critical enterprise services and putting them across all 3 sites so that we could guarantee that if any one site goes down or has significant issues, no one would ever notice. We're trying to get the rest of the portfolio to that state, but we consider them all equal, and when we add another site, it will also be a co-equal.
How are you sizing your quotas for your developers? How do you
That's a very delicate and messy thing where we spend a lot of time fine-tuning.
Yeah, it's current. Oh yeah, how do we define quotas for our application teams? It's on a team-by-team basis. So within our config management, we have basically defaults that we hand out to every team. And when they need more, they come and ask, or actually we have it down to where they can actually submit a merge request to our code if they wanted, and override those defaults. So if they needed more memory requests or more storage, anything that we capture in our quotas, they can override that as needed. Our config management will then go through all the clusters and update.
Actually, I want to stop right there and just point that out. That's something I think something that we've done that's really cool. The self-services capabilities that are not exposed through OpenShift themselves, basically around quotas for storage or network egress rules so that teams can manage firewall rules for themselves. We've built that into our standard deployment pipeline system, right? We put them into Git, they go through the pipeline, and they get automatically deployed, which means the things that OpenShift doesn't provide for you, we have developers using their native tools. They're already working in Git and with pipelines every day, so they don't need to figure out how to do things. They already have Jenkins pulled up, so when they need to go through it, it's there. And I think that also really helps us make this be a more natural platform for developers. And I think that's just an interesting way to do things.
Right, and you see I'm not almost talking because I don't have to think about that anymore. I just need to work on my code, and pretty much just using the tools I'm provided, they kind of give me everything I need, the egress rules and all that, and so I don't have to bug those guys constantly.
Sorry to take a little tangent there. Oh, sorry.
You mentioned
So that is where we're going next. We actually have Mongo still running in infrastructure as a service for now. One of the key things is getting our DBAs trained up on running things in an ephemeral environment that goes down a lot. One of the things we're really excited about is actually the OpenShift operators that allow Mongo databases to be deployed, upgraded, run, backed up, the entire lifecycle managed in an automatic fashion. That should allow us to scale our DBAs tremendously. They'll be able to focus on schema tuning and optimization and let OpenShift handle all the work. So that's also something that we are actively trying to figure out how to do right now. But we've actually found a lot of success with keeping our databases outside of OpenShift, because one of the things OpenShift is best at is it's enabling developers to develop better and faster. So we've seen tremendous advantages on trying to spend our time getting developers to adopt the program, the platform. If we can get DBAs to do it also, that's great, but databases don't change as frequently. Code, we want to be able to change code in 30 minutes and get it out to prod. If a database takes a week, that's probably okay.
You guys consciously deployed dev prod, QA, and prod clusters, or was it?
So we do have separation between our production environments and our non-production environments, but within non-production, you can set up whatever non-production environments you need. So our standard is dev and integration, but some teams have like dev and QA and user acceptance testing and automated testing and a whole variety of other environments. And in prod, most teams just have prod or they have stage in prod, but we're starting to see teams experiment with blue-green environments or whatever other deployment patterns they're interested in. No. So all of the prod, in each site, we have a pre-prod cluster and a prod cluster, and all of the prod projects, if blue-green stage prod, are in the prod. All the projects are in the prod cluster, and all of the pre-prod projects, dev, QA, int, whatever, are in the pre-prod cluster. So we haven't had to spin up 20 different clusters. We have 2 clusters per site for a total of 6. Yes, we do. So technically we have 7. And with OpenShift 4, we actually have done testing outside of that so that we can still test things on 3.11 while we're working with 4.0. But that'll shrink back down once we move everything to 4.
Did you guys evolve this DevOps environment from OSP, or is OSP still used somewhere? You mentioned IaaS, that OpenStack, or?
So we actually are not using OpenStack underneath these clusters. We're mostly still running on Rev. We're migrating to OpenStack right now. These DevOps practices just evolved naturally out of OpenShift. We've been working on OpenShift since OpenShift 1, so we started to see the possibilities back with OpenShift 1 before it was containers, when it was still written in Ruby, and it's just evolved over time. So that's the origin of all of this stuff, honestly.
So talk about what do you do with OSP as complementary to this?
So we are one of the other projects working on right now is integrating OSP into this. We can fit most of our applications into the PaaS, but there are legacy applications which are more difficult to containerize. So that's where we're going to see multi-site capabilities using OpenStack and other technologies. But because we knew that most applications could fit in OpenShift, that's where we'd get the most bang for the buck. That's where we focused first.
Yeah. What do you have in front of your routers? Do you have BIP or do you use DNS?
So what do we have in front of our routers? That's actually a little bit complicated because in each environment, prod or pre-prod, we actually have multiple sets of routers that are separated at a network level. We have, for instance, one set of routers that are directly exposed to the internet and another set of routers that are used to front Akamai services and other load balancing services that limit who can access them. So that means people have to go through the CDN to get to our services. And depending on which path you take, you go through different sets of firewalls and different sets of network routing. But we do secure them at a network level. We do have firewalls. We expose only certain ports. Does that help?
No, I'm thinking about if I go to...
Oh, LTM, local traffic management. So in Amazon, we are using ALBs now.
ELB.
ELBs, sorry. And in our data centers, we use F5 load balancers, but we do that in the dumbest possible way just to balance traffic and consistently route it. Nothing fancy. We just want the traffic to get to an active router so the router can pick up the traffic and pass it back to the service.
Yeah, so they have the same name, like a record, or so how?
Each site has its own name, and then we have global load balancing in front of it that routes people to the right place. Name or IP, I should say.
Are they, how are they, I don't know.
It's just a layered approach, right? If you're coming in and hitting like redhat.com, you'd hit Akamai. Akamai would route you to one of our sites. There, you'd go to the local traffic manager, and from there, you get routed to one of the OpenShift router nodes, and from there, you get routed to the OpenShift service and then to the pods. Akamai or other global load balancing solutions, yeah.
Right. Yeah. So that's all the time we have for
Yeah.
questions.
We'll be
Thank you
hanging
for
out
the
here out in the
discussion.
hallway.
Yeah.
So
thank
yeah.
you.
Thank you.